Say, for example, that we all work for a company called Sherling Enterprises. And in our company, what we do is we take steel rods like these, and then we cut them into pieces and then sell them. Now, to make things simpler, we assume that cutting the rod into pieces does not cost any money. Given a piece of rod, what we would like to do is cut it into pieces so that we make the maximum money or maximum revenue out of selling those pieces. Now, you might think that, well, a steel rod may intuitively be, the pricing may be something like the first 1 inch will cost me, say, $1, the 2-inch piece will cost me $2, a 3-inch piece will cost me $3, and so on. But interestingly, that's not the case in this problem. The market demand is slightly different. Here's how the demand looks like. The price for a 1-inch piece is $1. Suddenly, the price for a 2-inch piece is $5. And then the price for a 3-inch piece is $8. The price for a 4-inch piece is $9, and so on. So obviously, the longer a piece, the more costlier it'll be, but it's not uniform, as you can see, right? Now the question is, so we have a rod like this. What we want to do is break it into pieces such that we make maximum revenue. Now you might think that, well, if I'm always getting a same size rod as input, then why don't we come up with the best answer and then we settle down for it, right? The problem is that we need an algorithm because these prices could change over time. Also, the size of rods that we receive may also change over time. So if we have a static answer that stays same, then that may not work. Every time we have to come up with an answer. So instead, what we need is an algorithm that, given this table of rod lengths and prices and a new rod of a length X, an algorithm that determines the best cuts to make the maximum revenue. Some of the prices, as you will see, are funny. For example, a rod of length 7 inches and 6 inches both cost $17. So if you actually have a rod of length 7, say you are given a rod of length 7 and you want to sell it right after cutting it, then the obvious question is, should I sell it as it is or should I cut it, right? So then you can see that obviously if I have a rod of length 7 inches, then instead of selling it as it is wiser to cut it into 2 pieces. The first piece will be of length 6 inches and the second piece will be of length 1 inches, right? This way I will make $18 because $17 will obviously come from the 6-inch piece and then $1 will come from the 1-inch piece. If you look carefully at the table, you will see that it further makes sense to further cut the 6-inch into 2 pieces, right? If I cut this 6-inch into 2 pieces of 3-inch each, then the amount of money I'm going to make is $16, right? So if I cut the 6-inch piece into 2 pieces, I'm going to make $16. But if I sell it as it is, then I'm going to make $17. So at this point, it's not wiser to cut this rod into further any pieces, right? So these are the kind of sort of decisions that we want our algorithm to look at and finally come up with the optimal cutting. Now, something interesting to note is that there may be multiple ways to cut a rod to obtain the same revenue, right? There may not necessarily be a single solution to obtain the maximum revenue.